Today's lesson is on reciprocal trigonometric functions and values of angles using QRST. All right, we're going to start by looking at our unit circle, and we're going to fill in a table. And on our assignments, we're going to keep filling in like a brief table of the first quadrant, because what we're going to be using are these first quadrant values. All right, so I'm going to set up and have my table where I say 90, 60, 45, 30, and 0, rather going in order because this is the way we see them in the unit circle. Okay, so the first thing I want to do is list what are my radians. So the radians for 90 are pi over 2. For 60 are pi over 3. 45 is pi over 4. 30 is pi over 6. And 0 is 0. Okay, and I know that the cosine is the x value, the sine is the y value, and these are the coordinates, and tangent is y divided by x. A basic review, 0 divided by any number is 0, and any number divided by 0 is undefined. Okay. So looking at the quick way of filling this in, for 90 degrees, my x value, which is cosine, is 0. My y value is 1. And my tangent, y divided by x, is 1 divided by 0 is undefined. Okay. So these are just my coordinates. So 60, 45, and 30, I'm just looking at these, and how I fill these in is I write these in as 1, 2, 3. I go back and put 1, 2, 3. Everything is over 2. And then I'm going to take the square root of the numerators. The square root of 1 is 1, so I don't need that. So just on the 2's and the 3's, I need square roots. So poof, I got all these. So these are the coordinates for the first quadrant. At 0 degrees, I'm on the right there. X is 1, y is 0. Okay, to find the tangents, I'm just doing y divided by x. So the square root of 3 divided by 2 divided by 1 divided by 2 is just the square root of 3. Square root of 2 divided by the square root of 2 is 1. 1/2 divided by the square root of 3 over 2 is either 1 divided by the square root of 3 or rationalize the square root of 3 over 3. And I would recognize this in both forms because we're going to see it in both forms. And 0 divided by 1 is 0. So I kind of make this table on all my assignments. The more times you make this table, the quicker it comes out. And it really doesn't take very long if I do it with 1, 2, 3, 1, 2, 3, all over 2, and then take the square roots. Okay, so for today's lesson, I'm going to be using this table because I am not using a calculator. So my learning objective for today is I can evaluate trigonometric functions of acute angles without a calculator by applying QRST, ASTC, and primary and reciprocal together. Okay, so reciprocal means I am going to switch my numerator and my denominator. So in the past, we've kind of done just numbers, but now we're doing this with trig. Okay, so we have worked with the primary functions for the trig functions are sine, cosine, and tangent. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay, so I'm just flipping my numerator and my denominator. So if sine is y over r, the reciprocal cosecant is r divided by y. If cosine is x divided by r, the reciprocal secant is r divided by x. If tangent is defined as y over r, then the reciprocal cotangent is x divided by y. Okay, so let's go through abbreviations real quick. So sine, everybody should be aware of, is SIN, but I say the word the whole time. Cosine is COS. Tangent is TAN. Cosecant is CSC, but I say cosecant. Secant is SEC. And cotangent is COT. Part of how I personally remember when I'm first learning these, I remembered that sine and cosecant go together. So I have a C and a S that go together. And cosine and secant go together. So I have a C and a S that go together. Everybody remembers tangent and cotangent. But if it helps with the cosine, secant, sine, cosecant, do whatever you need to memorize these, because we're going to be using these for quite a while. Okay, so we started out where we said that each trig function is positive and negative in 2 quadrants each. And we're going to expand that because it doesn't matter whether I have the primary function or the reciprocal function, whether I'm positive or negative. It doesn't matter what's in the numerator and what's in the denominator. So we said all 6 functions are primary and are positive in the first quadrant. Okay. And then everybody else they're positive in one more quadrant, and then they're negative in the other 2 quadrants. So what other quadrants? We said sine. So sine and cosecant, cosine and secant, tangent and cotangent are all positive in the first quadrant. So we use the acronym all students take calculus. So all students take calculus. So in the second quadrant, sine is positive and its reciprocal cosecant. T stands for tangent, so tangent and its reciprocal cotangent are positive. And takes calculus is cosine, is also positive in this quadrant. So the all students take calculus refer to the primary function, not the reciprocal function's letters. All right, so let's do some problems here. All right, so we're going to learn something else new today called QRST. So we are going to evaluate these, and the intent is to do this without a calculator or without looking at your unit circle, because you are just making that first quadrant and we're using that information. Okay, so Q stands for quadrant, R stands for my reference angle. Reference angle is always measured to the x-axis. Sine, am I positive or negative? And T is for my trig ratio. Okay, so let's do the first one. First one says I have 150 degrees. So it is positive. So I'm just sketching out real quick my angle here. My angle, 150 degrees puts me about here. Whoops. Puts me about here. So here's 150 degrees. I'm going in the positive rotation here. I know that cosine is defined as my x coordinate. So let's start filling out. Q stands for quadrant. I'm in the second quadrant. My reference angle, so here's my reference angle, always takes me to the x-axis. So if this is 180 degrees, my reference angle alpha is 30 degrees. 180 minus 150 is 30. So my reference angle is 30 degrees. My S stands for sine, and I know cosine is negative in the second quadrant. And the trig, so now I'm putting it all together. So my trig function is cosine. So I'm doing negative. So my sine here is negative cosine. So I'm bringing cosine down here, 30 degrees. So from my unit circle, I know that my cosine of 30 degrees is the square root of 3 over 2. So I want negative square root of 3 over 2 as my answer. So I'm interested in exact answers, nothing rounded. All right, let's try another one. 330 degrees. So first thing I'm going to do is graph this. I know this is putting me over here in the third quadrant. 330 degrees. So I'm going in the positive rotation here. I know sine by definition is y. So I'm in quadrant number 4. I'm interested in what r is my reference angle. So my reference angle to the x-axis here, so this is 360 degrees. So alpha equals 30 degrees. 360 minus 30. So my reference angle is 30 degrees. My sine, so I want to know what is the sine of y in the fourth quadrant is negative. So my trig function, so I'm talking about sine, so negative sine of 30 degrees. So I'm putting it all together. So I know the sine of 30 degrees is 1/2, so I want negative 1/2. So I'm just applying the sine. I'm using the first quadrant information, but then applying the sine based on what quadrant I'm in. All right, let's try another one. Okay, tangent of 240 degrees. Again, I am going in the positive rotation. So here is 180. So 240 will put me in a third quadrant. So I'm in quadrant 3. So my reference angle. So I'm going to take 240 minus 180. I'm going to get 60. So my reference angle is 60 degrees. So tangent is y over x. And x and y are both negative in the third quadrant. So the sign of tangent is positive. All students take calculus. So tangent is positive in the third quadrant. So this is the positive tangent of 60 degrees. And the tangent of 60 is the square root of 3. So you're just looking these up on that quadrant 1 chart that you made. When you write it on every paper in the unit circle, you will know all of these by heart. If you always have to go refer to it instead of write it down, you'll struggle the whole unit. All right, next one. Let's try one in the negative rotation. So this is negative 120 degrees. So here is negative 180 degrees. So this is putting me on quadrant 3. Here's my reference angle to the x-axis here. So 180 minus 120 is 60 degrees. Reference angle is always positive. Okay, so now we're talking about cosecant, and cosecant is 1 over sine. So this is 1 over y. So is y positive or negative in the third quadrant? And y is negative in the third quadrant. So this is going to be the reciprocal of negative sine of 60 degrees. So this is going to be the square root of 3 over 2, but I want the reciprocal. So this is going to be negative 2 divided by the square root of 3. And I have a radical in the denominator, so I need to rationalize my denominator. So I'm going to multiply times 1 in the form of square root of 3 over 3. So this is going to be negative 2 times the square root of 3 over 3. So just take it one step at a time, the QRST, and just follow down. Okay, let's try the next one, cotangent. So this is another reciprocal function. This time going in the positive rotation. I'm in radians this time, so I'm interested in what's in the denominator. So I'm going to change pi into what the denominator is as 6 over 6. So this is 5/6. So 5 pi over 6. So here is my reference angle to the x-axis. So I'm in the second quadrant. My reference angle is pi over 6. 6/6 minus 5/6 is 1/6. So pi over 6. I prefer at this point to work with these in degrees. So pi over 6 is 30 degrees. You can work either way. So cotangent is 1 over tangent, right? So tangent, I'm doing all students take calculus. So tangent is negative in the second quadrant because it's positive in the first and the third. So negative in the second quadrant. So this is negative. Oh, I'm sorry. We're in a reciprocal. We have a reciprocal. Reciprocal of negative tangent 30 degrees. So the tangent of 30 is 1 over the square root of 3. So the reciprocal and the negative is going to be negative square root of 3. So this is why I said I would make sure I understand tangent in both forms. Okay, 2 more examples. Oops. Cotangent of 540 degrees. So cotangent, I'm going in the positive direction here. So I'm going to find a coterminal angle by taking out one rotation. So I'm going to subtract 360. And I get 180 degrees. So I'm actually on the negative y-axis. So I'm over here. So this is my angle here. So quadrant, I'm not in a quadrant, so that does not apply. When I am on an axis, I do not have a reference angle, so that does not apply. The sign is that I do not apply if I don't have all this other stuff. So I realize this is a point, so this is negative 1, 0 is what I have. So I'm looking at cotangent is 1 over tangent. And I know tangent is y over x. So cotangent is x divided by y. So here is x is -1 and y is 0. So this is -1 divided by 0. And anything divided by 0 is undefined. Okay, so my answer is undefined. So if I have a point that's on an axis, I'm using those coordinates. Okay, last one. This is drawing the triangle. If the secant of theta is -7/2, and theta is located in the second quadrant, find the 5 other trigonometric functions. Okay, so I am first drawing my triangle in the second quadrant. So that's what the directions say. Okay, the right angle is always perpendicular to the x-axis. Theta is always over by the origin. My radius is the hypotenuse. Now secant is 1 over cosine. So this is 1 over cosine. So cosine is x over r. So this is r divided by x. So the radius is always positive. So I know the radius is 7. And I know in the second quadrant, x is negative. So the negative sign goes with the denominator. So x equals -2. My radius equals 7. And I need to calculate y. So I'm just applying equation for a circle, which is x squared plus y squared equals my radius squared. X squared is -2 quantity squared plus y squared equals my radius squared, and the radius is 7. So 7 squared. So 4 plus y squared equals 49. I'm going to subtract 4 from both sides and I get y squared equals 45. I want to take the square root of both sides. And I know that I can simplify 45 with a perfect square with 9 times 5. So I get y equals 3 times the square root of 5. Okay, so substituting in now, I know x, y, and r. So the sine of theta is y, which is 3 times the square root of 5, divided by my radius of 7. My cosine is x divided by r, and x is -2 divided by 7. My tangent is y divided by x. Y is 3 times the square root of 5 divided by -2. Cosecant is going to be the reciprocal of the secant. So I know this is going to be 7 divided by 3 times the square root of 5. I need to rationalize the denominator. So square root of 5 times the square root of 5. So I know the square root of 5 times the square root of 5 is 5. So 7 times the square root of 5. And 3 times 5 is 15. And cotangent is the reciprocal of tangent. So I know this is going to be -2 divided by 3 times the square root of 5. Again, I need to rationalize the denominator. So square root of 5 times the square root of 5. So -2 times the square root of 5 divided by 3 times 5 is 15. We got it.